Hello everyone, my name is Samit. I and Jack work with Formic AI as machine learning associate as part of this FastLane projects cohort. And today we'll be presenting our presentation, CanDoo, Reshaping Legal Research with AI. So to tell you more about the Formic AI, it's a small scale enterprise who has a mission of providing domain specific LLMs that users can trust. And currently Formic AI are providing services in legal domain. And they have a product called CanDoo AI, which is essentially a Chrome extension on online database called CanDoo, and they have three services in that CanDoo AI product, which are Query Composer, Case Chat, and PDF Chat. We will see about those services in the upcoming slides. To give you the overview of this use case, currently legal professionals are finding it hard to search for relevant cases. And once they find relevant cases, they have to go through each and every case, which can be approximately like 150 pages. They have to manually read it, and they have to note down all the relevant points for their arguments. So there's a need where legal professionals can converse with documents in a natural language, and there's a need for a natural language interface so that they can find the relevant documents quickly. To tackle this problem, or for this need, we are proposing a chatbot which can convert user natural language queries into boolean queries. We will see them in a bit. We are also proposing some advancement to their current features, and we will prove them statistically that they have improved. And by this, we will provide a RAG-based application at the end where legal professionals can chat with the cases. So this is their first service, which is called Query Composer. Canly is an online database for Canadian legal documents. So once you go on website, you put your natural language query, and as you can see, the first case is from Alberta, which is not from Toronto, as specified in the query, and the fifth search result is also from different province. So it is really hard to find the relevant case data. So what's the solution for this? So database provides us with some operators, and we can come up with a Boolean query, which can be seen on the right side. And through these Boolean queries, we can really find those false negatives, which were hidden from the natural language query. As a programmer's perspective, it is easier for me to go over these operators and build maybe a Boolean query. But for legal professionals, it's really hard to come up with these kind of logical queries. So we are proposing this chatbot. And as you can see, if we add more synonyms in the query, it really helps to find those false negatives because everyone has different style of writing. So this is just like a high-level overview of the solution where we take the natural language query, we filter some dates and locations, which are standard filters on the database. Then we pass it through WordNet, Glow embeddings, and we have collected some internal legal corpus of about 30,000 keywords and phrases. And then we do a similarity search and find synonyms and legal phrases. We also take the help of case search snippets, which are the small text behind the cases, and we can really find some useful keywords to show to the user. And at the end, user will be shown all of these synonyms and keywords, and they can select what they want and what they don't want. This is a final demo of the Query Composer. You can see it has synonyms at start. It has legal exact matches. Then it suggests some phrases and words which are legal specific. And on the left hand side, you can see previously the synonyms provided were not really great. And through our solution, we can see the improvement in legal synonym findings.
So now we'll move on to another part of the product of CanDoo that Formic AI offers. This is case chat here. So now after you've found the documents that you have deemed to be relevant, hopefully using our lovely boolean search query query composer results, you can see that once you click on a document, we're able to create what we call a case memo on the side. So this is an automatic summary of the document along with a list of facts, the list of issues that the lawyers came to the court with, and then the list of ratios, which are the legal principles that were used to determine what the outcome of the case actually is. So recently Formic and our engineers introduced version 2, so we've implemented an improved version of our case memos, but how do we know exactly that we've actually improved our tool? A lot of summarization and question answering tasks, as we know, are generally pretty nebulous. It's difficult to really figure out if you have a better answer to a question without relying on some of these other metrics that can be very finicky and don't necessarily actually convey semantic meaning the way that we want them to. So we have a problem of difficult tasks like question answering, and then on top of that, we don't have any labeled data as well. So how can we tell if our task is actually improved or not? Well, we're going to implement our own benchmark that we have created internally using an LLM as a judge. So what we do is that we've taken the results of our version 1 of our case memos product, and we've also taken the results of version 2, and we've sent them through the same benchmark, which is essentially asking some of the largely available LLMs like ChatGPT, Claude, and a few others to see if they prefer the response of version 1 or version 2. And then we did some statistical validation, including using some chi-square tests. And then after we figured out which one of these models was the best, we ended up deploying that to our actual CanDoo case memo product. There were a few other things that we did to make sure that all this was validated, including using one of our in-house legal experts to make sure that our LLMs were actually sound and statistically valid. And we did some inter-observer agreement statistics to make sure that what our benchmark was measuring was actually correct. And we figured out which version of the model, as I was saying, we ended up using, and now it's deployed to our CanDoo application. So let's get onto a bit of our extended scope goals now. We've improved what we set out to do at the start of our project. So now our hope is to improve the company as a whole, which is to move away from the constant and hopefully unnecessary API calls. As everybody knows, using outside APIs for your internal products can be very problematic, including having to use the constant expenses of making these API calls to these large language models. There's also all the issues of privacy concerns, especially when you partner with different firms. A lot of them are not interested in having their internal data be sent out to Google or OpenAI or something else. So what we have figured out we need a need for is an in-house large language model to perform a lot of these question answering tasks for us. So what we did was that we have started training some of our internal LLMs, starting from the very bottom of some randomly initialized weights and pre-tuning on an entirely in-house data set as well that our engineers have collected over the last little bit. We spun up a huge cluster of about 36 GPUs, so just over 1 terabyte of compute. And we have been training it for the last month and a bit so on just under about 1 trillion tokens now. And at the moment, we're just doing some evaluation on some question answering tasks and doing some instruct fine tuning. And we're hoping that we'll be able to eventually switch out the calls of APIs with our own internal models. So to sum everything up, we've left Formic with a decent amount of value over these last few months. We've given them a competitive edge over some of the other legal tech companies because Query Composer is the very first of the general natural language to Boolean query creators. And on top of that, we think that our users are really going to enjoy the more hands-on experience of instead of just generating a query for them themselves, they can select their own words that they prefer to use. And we've assisted our lawyers since that tool will assist them in our goal of finding more relevant cases. We statistically validated one of their new products, and we're able to use this same validation tool for future versions as well as the company continues to make new versions of the product. And then on top of that, we've given our firm an ability to potentially customize to different firms and their different needs. Now that we have our own in-house language models, we can fine-tune them to the specific needs of the different firms or companies that we could partner with, and wouldn't have all the privacy concerns of having to use all these external APIs. And we really appreciate you listening to our presentation, and we hope you enjoyed it. And if there's any questions, please let us know. Thank you.
Are you training one LLM from scratch or using? Sorry.
Say it again, sorry?
You mentioned you're training an LLM with quite a, is it the tokens that they're training one from scratch? Or,
Indeed, yeah.
Any reason why you?
Yeah, so our company has been experimenting with a lot of the publicly available LLMs, both those that are, you know, available via APIs or just on something like a Hugging Face ecosystem. And in general, the hallucination problem is still a very big issue. A lot of these models tend to defer back to language that they seem to have learned or some kind of information that they seem to have in their weights via either from the pre fine-tuning stage or whether they be from the fine-tuning itself. So we've collected an internal data set that we think really describes the general purpose of what we hope it to do, and we believe that by fine-tuning our own data sets, we'll hopefully get a little bit more aligned with what we want these models to do.
Thank you, guys.